Hey guys, let's talk quickly about using function composition with inverse functions. So before you start with this topic, you need to have a pretty strong understanding of what is function composition, how it works, and what are inverse functions and how do we find them. Once you kind of know those two pieces, I'm going to show you how these two pieces kind of work together. So before we jump into the problem, here's the deal. When you do a function composition, such as f of g of x. If you do f of g of x, which is the same as taking the g function and substituting it into the f function, if you take g and plug it into f, you go and simplify it, and when you're done simplifying, you're left with just a plain old x. What that means is the function f and the function g are inverses of each other. Okay, that's only if you're left with just a plain old x. This can work the opposite way as well. If you do g of f of x, which again, that's just like taking the f function and plugging it into the g function, you simplify this and you get a plain old x. That means g and f are inverses of each other. If during the simplification process you're not left with a plain old x, that just means those two functions are not inverses of each other. So let me show you what this looks like in action. So I have f of x equals x squared minus 5, g of x equals the square root of x plus 5. What I'm going to try and do is I'm going to use function composition to determine, are they inverses of each other, yes or no. So what I'm going to do is I'm just going to start with, let's do g of f of x. So g of, don't know what I'm writing there, g of f of x. So essentially what that means is I'm going to take the f function and I'm going to plug it into the g function, g of f of x. So visually, I'm going to take the f function, which is x squared minus 5. I'm going to plug it in for all x values into the g function. So I'm going to rewrite this guy, but anytime I run into an x, I'm just going to put an x squared minus 5 in its place. So what this looks like is, well, I need a square root, so there's my square root. I would need an x, so I'm going to put an x squared minus 5 in its place. And then I need a plus 5. What I'm going to do is I'm now going to simplify this expression. So looking at it, on the inside of the square root, I have a minus 5 and a plus 5. Minus 5 plus 5 is 0, so those are gone, and I would be left with still the square root and an x squared. Then I'm looking at it, trying to simplify. I have a square and a square root. Square and square roots are inverses of each other. Those are gone, so then you're just left with a plain old x. So what this means is, since I simplified, it means f and g are inverses of each other. Okay? That's only because we simplified to a plain old x when I use the function composition. So, you might be wondering, well, what does it look like if they aren't inverses? So my next example here, I have a new f function, a new g function. Let's go the opposite way this time. Let's do f of g of x, which again, that's like taking the g function and plugging it into the f function. So I'm going to take the g function, which is x minus 8 divided by 5, and I'm going to plug it into the f function. So what this is going to look like is, well, you still need a 5, so there's my 5. I'm going to plug in this this x minus 8 divided by 5 in the spot of x. Not a bad idea to use parentheses there. There's my x minus 8 over 5. So this g function took the place of the x in this f of x function. So I have my 5, took care of the x, just need a minus 8 off the back. So if I go to simplify this, well, I'm multiplying by 5 and I'm also dividing by 5 at the same time. So when you're multiplying and dividing by 5, those are inverse operations. They are gone, so I'm just left with the x minus 8 there and still the minus 8 out back. Trying to continue to simplify, I got a minus 8 and minus 8. Those can be combined to x minus now 16, because negative 8 is negative 16. That's as far as I can go as far as simplifying. So what we have here is, I did f of g of x. I did not get a plain old x. So what do we know? F and G are not inverses of each other. Okay, and you could do this for all sorts of functions. You just use that function composition. You can do f of g of x. If it simplifies to x, you got a function. If it works this way, the other one should work as well. So if you do g of f of x, it should simplify to an x. If you don't simplify to a plain old x, they are not inverses of each other. And that was using function composition with inverse function.